All right. First off, first most, every single all credit goes to these individuals here, especially Dr. Sanchez. He made most of this content, and hopefully we can begin. So what we're gonna do is do what we call ramjets, and we're gonna do super declinative and super deep. I can't say it correctly. I don't know why I can't say the D word properly today. Yeah, there's certain days that I don't know why. But it's super subdeclinative, declinative, and super declinative. Okay, I'm just gonna stop. I'm embarrassing myself at this point. I don't know why I can't say it correctly. It's just my luck today, I guess. But we're going to begin by starting with drawing it out because we should always start with that. Um, okay, I don't know why I'm struggling to say words. Come on, brain. You can work here. Brain, so come on, draw correctly. Straight lines, man. Right, straight lines. We have a triangle over here, right? Okay. And we're gonna have to go jump to Desmos continuously because I am not using table method. I am gonna use what we call a graph method, which I don't know what I'm saying with that. Basically, I'm just gonna use the method of using the what we call the Desmos graphing calculator. We're just gonna plug functions in there to make sure everything is correct. It's the easiest way for me to double check if everything is correct. You'll see why later. But hopefully my internet is not laggy because I feel like it's getting laggy. There's a combustion here. And then M5 equal 1 because what happens is that there's a shock wave, so and it's a perpendicular shock wave, so this must be 1. So they're saying there's the difference between P M4 and M5. I don't think there is. Is there? Let me double check if there is, but no, I think yeah, I might be wrong. I think I'm wrong. Okay, I am. This is a subdenivative. I'm basically double checking everything to make sure everything's correct because over here there's a lot of numbers, so there could be wrong things somewhere here. So I'm double checking everything now. I'm sure it's all correct. Honestly, it's a rare. We're going here to here. There's the M2, M3. There's an expansion over here, and there's an M4, MP4, and then there's an M1, P1, and then H1 like this. It's a beautiful way. Oh, there's combustion here too. It's a beautiful equation basically. And I'm gonna 1.5 times it, so it's better for everyone to just listen to it. So the ramjet is operating in two different ways. It's called the subdetonative mode. Ignition occurs in a downstream normal shock as a supersonic heat. Basically, is what's happening. And in the other case, it is a super detonative mode, which combustion takes place in the middle and behind the oblique shock, basically. And what we learned before is basically we need to get a perspective here. If I remember correctly, it's like this gives you a shock, a oblique shock, right? Let me see if you can see that. No, you can't. So let me just cool oblique shock. So if this is going straight over here, this is also this is the example of this one over here states that we have AL, which is basically AL divided by AT equal to 0.4. Okay, we have that. We have assumed that consider projected motion for single system for city shock, two-way shock. Okay, there's a deflection of 15%, 15. Okay, and M1 is 3.5. Okay. This looks like this is a huge equation, which means this is a hard question. Honestly, if it was an exam question, just this question would take probably an hour for me to finish. I'm not joking about that one. It might actually do that. So the first thing I have to do is the straightforward idea about oblique shocks, right? I need to bring those equations up. I don't know where I put them. So I'm just gonna find them, do Dr. Sanchez's notes here and there. We will see where it is. Uh, and we'll double check everything here. I think it's this here. Gee, if I'm not wrong. Okay, yes, it's a oblique shock, so I believe this should be correct. Because oblique shock at the end of the day is the same as, other shock waves. So we probably should just use the graph, honestly. I don't know why I decided to bring this up when we need the graph too. Let me just bring out the graph. I don't know what kind of chart it's called. Well, I'm definitely not going to solve the big equation. I'm just going to do the graph method, which is, in my opinion, I'm screenshotting this. I really should. It's going to get laggy, and you're not going to be able to see anything. I have done this before. Basically, what happens is more screenshot, the more laggy it gets. But I can't be bothered right now, so we're going to use this method here. And now from my knowledge scape over here, we know it's going to be m equal 3.5, which is over here. Oh, that's very thick, I must say. Okay. And then its deflection is about 15, right? 15 is over here. You can see that, right? I hope you can. If you can, here is my mistake that I kept on making for the last few minutes. This over here is a sine. But that said, we have everything we can possibly want. And I was trying to figure out why a little bit of the numbers are off, and I think it's because I rounded up over here. So I generally think I need to just double check my math, but that seems pretty close to what the prof got. Yeah, here's the thing. I think for once in my life, I'm gonna do what I said I would never do and not use the graph. Yeah. I think I have to because I am not getting. So I'm gonna double check the proper way I should have been doing a long time ago. Okay, here's the actual answer. So you know how I do things to take equations. I don't do it this way, but yeah, clearly I've made a mistake here. You can see over here by looking at Desmos that this is what I get, 29.2. So that would mean I need to change these numbers to 29.2, basically. 29.2. Okay, and that gives me these two numbers. Okay. Now this gets me into a region that I mean way more accurate than normal, but this gets me into over here, this region over here, and then this region over here. Now we need to get M2 over here, right? And how we're going to do that is the same thing, and how I'm going to explain how this is done. Over here, we have something that looks like this, but the velocity is going this way, right? Now, how this is going is that the initial point over here is where the shot goes in, so this is oblique again. And but this is definitely minus 1.4 plus 1. Okay, I get a Mach number, but that Mach number is suspiciously smaller than the Mach number before. Ah, yes, because we're doing a normal, so we need to, this is m underscore n. So you need to do MD, which is over here, MD, which is M underscore D, and this is the middle step, so it doesn't really matter, equal to divided by 0.67, and then it's going to be sine beta, which is, and plus delta, minus delta. Where is minus delta? I can already tell this video is going to be long, but I don't know what, I'm going to just yap. Hopefully that doesn't affect anyone. So it's 29 degrees minus, what, 15? Minus 15, which is 2.6. Okay, so I'm getting 2.6 for our region over there. And now we're doing a deflection again. And it was 3.5 initially, so it does make sense. So I'm going to keep on going because nothing here doesn't make sense yet. Okay, nothing here doesn't make sense yet, which is a good sign. It's a good sign that I'm doing something correct for once and not freaking out and doing something wrong. So over here we have MD, Next, we need to get, oh, we have to do this whole thing again. So we have to get 3.6 out here, and then we're going to get this to beta 2 point, so it's 1.2. And then finally, with that said, what's going to be M2? 1.7 is that point. So we get this response here. So everything seems to be in order. Um, yeah, ultimately everything seems to be in order. I get 2.5 for our P2, which means we just have to multiply P1, which we get 3.2, multiplied by 1.95. So it must be correct. As you can see here, we have done that. Yeah, it's getting really laggy now. All right. Now, next up, what's next in his notes? You have to obtain this by using this equation, which gives you M3. Yes, okay. That gives you M3. That is correct because it's not isentropic at all. It's not super declinative yet. I don't think that is wrong. I don't think that's wrong. Yeah, no, that sounds correct. Interesting. I'm just double checking something real quick. Huh. Okay. So, okay. Fair enough. We just have to now do this equation, which is basically the mass flow rate. The way he writes it down is by the following. Let me just go over here. Write it like this. So how he writes this basically M3 1 plus alpha minus 1 divided by 2 M3 squared parentheses negative alpha plus 1 2 parentheses alpha minus 1 equal AL divided by AT M squared 1 plus alpha minus 1 divided by 2 M squared 2 parentheses 1 divided by alpha plus 1 divided by 2 parentheses alpha minus 1. Does that make sense as a question? I think it does, but I have to double check as usual. Um, I am not double checking everything now. So what I know from previous and it seems right. There doesn't seem to be anything wrong with this one. Yeah, it's basically equation 4.25 just changed into this form. I don't see anything wrong with it. Check. Unless I made a mistake there. And with this, I can do the approximate method of scramming it. There's no reason for me to not do a mass flow rate. Yeah, that sounds right. Okay, so we have this. Let me just go to Desmos and graph it real quick. So it's 1.2, 0. What's the Mach number was M2. We're trying to get M3. So with that said, you can just get it from, and what was M3 again? M3 was 1.95, right? What was that? Am I smoking here? That sounds wrong. What is going on? Let me double check something. 2.9. Ah, so it's just the difference between 6 and 9. Okay. 5, 5. Okay, that sounds about correct. Just double check that. 2.95. That sounds about right. Let me double check with the prof. Yes, so that's about correct. Just put it in here. Yes. Now, with that said, we can use our other famous equation, which gives you the P1 divided by P2 equation. So let me just grab that and divide. Let me just 1.4 minus 1 divided by 2. And Mach number, what was it? I believe it was like 1.95 on the bottom one, so it's going to be 1.95 square. And it's going to be to alpha to what? Like, wasn't it like gamma 1.4 minus 1 divided by 1.4 minus 1? Something like that. I was kind of correct. So this is Mach 2 to 3, so 2 to 3, so 2 to 3. So we need 2, which is P2, which is Mach number is 1.95. Oh, then what is Mach number for here? It is actually 2.95, something like that, which would give me, why is it error? You wrote this like, oh, there's a comma here. There's a comma there. There's a comma here. I get 2.2. That seems correct. I think that's what the prof got too. So we have done it. There we go. There we go. All right. Is it worth noting that he? Okay. 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 So he wants us to get choke. Why would that's fine, I guess. But I guess we could solve it that way. Yeah. Yeah. To charge my phone too. Looks like. Um. Yeah. That's fair enough. That's correct. M3. What is M3? I don't know. Oh, he's telling you that you could have just used the table to figure this whole thing out, which is okay. Fair enough. Um, okay, so now we have to do a normal wave, basically the normal wave equation, which I should probably write down what these are because I don't think it's very helpful for me to just write this and just say, so this over here is the Mach number 3. Over here it is P3 over P2. And let me just do that real quick for all of them. Uh, wait, is it 3? This is Mach number 2, I believe. Uh, this is, I believe, P2 over P1, if I remember correctly, right? P2 over P1. Yes, I think that is P2 over P1. But I don't quite remember. 8.2, yes. Over here is intermediate steps, so we're just gonna let it go. And yeah, that's good enough. We'll move on. So we have that. What's the next step here? I'm gonna have to cut this like crazy. It's gonna be a long video. P5 over P4. Oh, so the combustion does something. Did not know that. Which yields to, oh yeah, because we have to use the following number. Okay, fair enough. I didn't even really think about that, which is my fault. Um, oh, I'm a dumbass for not thinking about that. Yeah, that is true. Okay, so the second thing I need is a jump discontinuity, which we can use the previous equation. Um, you have the Mach number, you have the normal. It's going to be Mach number 1. Basically, it's going to be choke. And that's it. That's, yeah, I think. I hope I'm right. I'm not flubbing here. I do genuinely hope I'm right. So we have the Mach number 3, right? So we have Mach number 3, which is this, and then we can just go put that into here. And then see, it's 2.95. I'm just double checking something real quick. 2.5. Oh, okay. Yeah, we will do that. And then, okay, another math mistake. I put a square on the bottom, which caused the problem. I'm a noob. But this is correct. It gives you the right thing. As you can see, difficult to edit a lot, but this is M4. And then I'm definitely gonna make a mistake in my calculator, that's for sure. Because I'm already messing up on the calculator here, which is funny. And then P3 over P4, which is over here, that. And we double check over here. Okay, I definitely messed up somewhere because I did 10 point something. What did I mess up in? I think it's because I chose 2 point. Oh, I see a mistake here. I then use 2.95, which is going to give me 9.985. Did he get the same? He got 10.03, and I refuse to believe that it is because of a rounding error. So I will double check. I got 9.9, which is could be a rounding error, but I'm going to double check everything. Be right back because I'm trying to be precise here. Okay, so a little bit of a rounding error. That's not really a big problem. Okay, fair enough. The problem I'm having is from this method over here is creating rounding errors by 0.002. Fair enough. That's perfectly valid. I will take that. Then this is P. I believe it was, what did they call it again? P4 or something. P4 over P5. P5 over no, it's P4 over P3. So P4 over here. So we got this. Okay, so we can round up to 10 over here, but because that's what the I've got. Next we're gonna use the equation, this equation, which I'm just gonna really this equation. Give me 5 minutes for me to figure out where this equation came from. I got where it came from. I got it. So this equation came from this one. It looked different because the m exit is 1. So this turns to 1, basically. So you know the gist of it now. Go to your calculator. Let me just do this real quick because I like double checking shit. Oh, what was my back entrance? That was 2.95, right? No, 0.47. This is the afterburners after the compression happens because of the shock. I love saying that. It's fun to say shock. All right, it's 0.5. Well, that sounds about correct. That's what he got too, basically. The rounding error is from my graphing error, so we should be good. So we are good. So everything seems to be consistent with what the professor got. The only mistake I'm making is rounding error from rounding it to the second or something, which is perfectly fine with me. I don't really mind that rounding error. It's not really a big issue for me. Although if it's a big issue for someone else, just tell me and I will start doing it more to what the we can also get Q over Q04. Uh it should be just 1. Why is it not giving the right answer? Did I not divide by something? Did I not divide? Did I not? It's 3.5 square, right? Oh, I'm square rooting 1.4. No, it should still be. Okay, I did something wrong. 1.4 minus 1 should be correct. Why am I fumbling here? It's 9.5. Parentheses 1 plus this minus. Oh, it's a plus. It's a minus. No, duh. Okay, we got it. I was like losing my mind there. Like, why is it wrong? I know I did it correctly. It's apparently this is why I am bad at calculators and I'm gonna mess up in the calculator section. I know for a fact I will. It's undoubtable. The mistakes I make with calculators is just embarrassing. Anyways, here is the final like number, which is 100% correct. With the professor's answer, right? Well, the error, the what? No, 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 something's wrong with my answer. Roof 1.51. We did this too. We did this with, oh, he rounded up. I think it's 1.6. Yeah, he did. He did. He rounded the 9.5. The error was in the me rounding up a little bit. It's fine. It's correct. Yeah. Um, yeah, it's correct. He did this. It's correct. The over here, if he didn't do the method I did, which is do this and went to more detail, it would have been the same. So he did it correct on the, yeah, on the Sonic. Everything's correct, so we're good. And my tablet is not working again. Great. Um, well, come on. Let me pause my. So while my tablet is reloading and rebooting, what we know is that we just did this part. And we just did this part, and it's 100%. The answer is similar, so we're good. So yes, the problem I was having is the same answer because I figured out 9.6 the same, and how we got 9.5 or 9.6 because that makes a difference of 0.2, but the difference is from accuracy from this portion over here, which is from my way of doing numerics, which is basically graph it and just hope you get a line like this. And I'm pretty sure it's from this one where I didn't really properly do it. Those small mistakes added up to 0.2, and that's why I was okay with it because I think I said earlier that it looks like it was an error of 0.2 earlier, so the error is 0.2, which makes sense. Which followed through my math. Um, Sometimes I get higher errors from doing this method. It's like sometimes I get like error of 1.5, and I was like, whatever. I did the right method at least. And yeah. All right, we're gonna continue now. I'm gonna move on. My tablet is still not loading, which is troubling me. But we can just type away in our calculator and figure everything out. Now we're gonna consider a super deductive case, which is basically the next case over here. And then I'm gonna go for more detail this time. This last time I didn't go for more detail, and it should mean the foot. So let me just go into the little bit more detail. We're gonna go into 24.22 as our degree, and then we'll do the same idea as we did last time. Oh, please not make a fucking algebraic mistake. You don't know how many times I've been fooled by algebra. Not really. No, sorry, by not algebra. What was it again? Fucking calculators. I keep on making mistakes with the calculator. Yes. You don't know how many times I have been fumbled in a environment because I made a mistake in the calculator, and next I'm spending hours trying to fix something. It's the most brain dead feeling in the world. Like it is really really interesting. The feeling you get from making a mistake in algebra is sorry in algebra in fucking oh my god, my brain's not working in a state of in math calculations with what you're supposed to be good at, but the calculator is interesting. Like it just gives you a little bit of a feeling of like, well, this happens. Do you get it? I don't know if you get it. I have that feeling sometimes, like, yeah, this is bound to happen one day. But that bound to happen one day happens like 16 times, and I'm just laughing my ass off. Oh, it's so funny. It happens like 16 times already. Every day, ooh, fucking mistake, algebra. And then it's just okay. What is the next black line? Maybe what? It is very big. Whoa. Yeah, last time I made a mistake of not going very small, so we're going to go very small. So I don't make that same mistake. Yeah. Okay, so we have this now, I think. Oh, I didn't show the intermediate steps. Ah, it's fine. Who cares? No, I do care. I say who cares, and I'm the one that cares the most. It's always funny. The person that cares the most is going to be the person that wants to get it. Get it? It's so funny. 172. 1 point. So it's 3.2. So it's multiplied by these two numbers. Ooh, what do you think it's gonna be? Well, it's supposed to be 14. So let's just check if it's 14 first. I get 15.47. What? Did I make a mistake again? Or is it a rounding error? Uh, well, let me double check the mock number and see if it's a rounding error or not, because I am very shocked that I found it, as if this is a real rounding error. This actually might be this time where either I fucked up horribly or I'm being too accurate here. I get 2.661. I think, I think I'm being too accurate here. I'm being too accurate? Well, we'll see. Apparently I get 15. And all the math lines up. I don't think I'm wrong. Let me just double check everything. But so you can see the answers over here is what I get. So 2.6, that's what the professor gets. So this is correct. This Mach 2 is definitely correct. Now this is P2 over P1, which they claim to be 14, but I get 15. No, I did this time I made sure it's a decimal point correctness. So I think it's a rounding. Okay, here's my first mistake. I think this is the first mistake you made. Okay, I'm sure it's 15.4. Okay, I'm gonna mark that. I get 15.4 here. I'll double check that, but if I'm right, then I need to double check I'm right. Uh, I can't find a mistake. What mistake did I make? I don't think I did. Hopefully not. Okay, I'm just gonna assume that I don't know. I think it's 15.4. I get 15.4. I'll double check later. Um, Next we have to do this part. Okay, so did we get? Oh, okay. I am slightly confused here. Let me check the chat. I might be fucked here. I might be wrong here. That's why I'm double checking everything. But I don't see a single mistake I made here. Um, and I don't understand why you need Q over H1 in the first one because I never used it. But the second one you definitely need it. So yeah. Okay. This one definitely I think is correct, right? There's no mistake here, right? I'm not flumming here. There's no mistake here, okay? Right? I don't know. Okay, I don't know. Oh, I'm double checking my map again. Okay. Oh, give me my calculator. I need to get my real calculator up and running. I think I found another mistake here. Let me double check and I'll be right back. I put the rest into. I need to take a number two. We're now in the deep end because I'm not sure if the answer is correct now. So we're just gonna have to keep on going. Is I can't find a mistake in my math. It's probably my mistake. I'll double check everything again later. Man, I'm gonna have to double check everything later. Anyways, because I'm pretty sure I got it wrong. Yeah, pretty sure I got it wrong. Anyways, next thing we're gonna do, we have to get M3, which is fair. Uh, we can get that by doing the FM equation, which you kind of already know. Is by plugging in our M3, which is where by doing X, it's going well, please don't make the same mistake 3 times. That would be embarrassing. Please, it's mock number one. Let me get mock number one, which is 5 squared. Please don't make the mistake 20 times. Okay. And then there's a square root of a half. Is it? No, no, no. I almost deleted my shit. Try to. And that should be the answer. Okay, so that apparently should be the answer. Please do not mess with me. Okay, I get the same answer as the professor gets. Yay! Oh, I'm really happy about this one, actually. This one was hard. Uh, Wait, why is it? Oh, it's 1.9. I could have just plugged that into a calculator and gotten it. I don't need to do all that. Okay, whatever. I got it now. I didn't need to do it that way. Here's the answer, but there's an easier way with a calculator. Yeah, don't worry about it. This gives me about, I believe, Mach M4 equals 1.91. Uh, yeah, I believe it's 1.91, which he gets, or is a zero. Yeah, close enough. The I get 0.90996. The professor gets 1.906. Same thing. All right, now we need to use our P divided by P divided by gamma divided by gamma. Okay, yeah, but you get the point. You don't have that equation on me. What? I'm shocked I don't have that equation on me. No, there must be a mistake. I'm sure I've written it down somewhere. Oh well, if I didn't write it down, I'll just redo everything again. Okay, so what's M2? M2 is 2.6, and then it's going to be parentheses square root of 2 by 1.9099, but I'm just going to use 6 because that's what the professor used. 1.7, yeah, that's about right. And if I choose 9, it would be the same, right? Yeah, it would have been the same. Yeah, it would have been the same. 9, 9. Yeah. So yeah, it's about the same. It's about the same. Okay, so we get this 1.72. 3. From that, I can now do this equation. What's M4 again? I don't remember. We're trying to get M4. Okay, so now we have this equation up here, which is 9, 9. Oh, let me just go home real quick. Well, this. Did I do this wrong again? No. Okay, there's a few mistakes here, I think, because I get this answer for the. Yeah, this goes up here. That's not. That's. Okay, I'm gonna have to recheck all the professor's math on the other one, and double check if everything's correct now because I found two mistakes already. Uh, Come on now, you can do this. Okay, so that would mean P4, it's not 2.16, 2.61, right? It's not 2.61, M3, what's M3? 1.99. Okay, so it would have been that, but with the change from this, okay, so this is the answer I get. 36 something was pretty much what I get. Take it or leave it, I believe that's the answer. So yeah, here's the answer, yeah. Which is interesting. That's the thrust, basically.